yung, ano yan eh, kasi it's a way to,
Abo.
okay, it's really a way to avoid self-deception. Yun yung point niyan eh, na how much you remember, and it helps na ma-review siya. Kung gusto mo ano yan eh, kung gusto mo mag-stay sa'yo yung skill, ang revisions daw ay you do, let's say, you study something now, and then a few weeks later, and then a few months later, and then a year later, yung gumagawa ka ng exercises.
Abo.
Ganon. Kasi, ang dahilan bakit ganon, kasi, para may period of forgetting. As strange as it may seem, yung trying to do an exercise when there has been some forgetting that has happened is actually more helpful than trying to put in everything all in one go.
Abo.
Yun yung ano, yun yung at least yun yung nababasa kong ano. And I think it works kasi isipin mo yung pag tinatanong ko, bakit alam mo pa rin to when you studied this N years ago? Kasi may mga nagtatanong sa akin eh. Okay, let's look at so simulan natin yung ano, yung topic natin for today, which is yung this is still from book 1 sa chapter 3. Ano yun, sinasagutan ko rin siya eh. So okay din yung ano niya, okay yung discussion niya. And it helps to look at the questions themselves. So, yung last na ginawa natin,
Abo.
di ba, yung a household use, yung practice now,
Practice na ito po.
yung practice now too. Okay. Tapos yung work example 3, practice now 3. Nasimulan mo na ba?
Abo.
Teka, para mag-compare tayo. Okay, so 174.96 or approximately 100 or nasa 175 degrees to the nearest dollar. Yung ang ano diyan, hindi natin ma-apply diyan yung rule na yung largest possible and smallest possible. At least not for the yung kasi hindi natin kung ano kung gaano ka-accurate yung measurements ng cubic meter, yung kilowatt hours at saka cubic meters eh. So, we'll just take that and then round off. Pero yung usual na ano, pansin yung rule of thumb na ginagamit, yung if you do calculations, rule of thumb doesn't always work, pero the usual rule of thumb is yung number of digits na sure ka, that dictates kung ano yung number of digits ng sagot. You have to round off to those many digits. Actually, babalikan yun dun sa next section. Dito, sasabihin, okay, round off here. Pero why? Hindi pa ano yan. Ngayon, tingnan natin yung sa yung mga sagot. So, 69 698,400 698 and then 700. Okay. One decimal place, 45.7. 46. Three decimal places. Okay, 45.740. Ngayon, yung sa 3A, number 3. Patingin. Ayan. Yung ano lang, so 160, kaya, so if you multiply it out, yung, okay, so perimeter is going to be 160 when you round off. So 164. Tapos yung area ng glass needed to fill up, kung rounded off, is going to be 1,500. Ngayon, before we move on from that question, kuha ka ng scratch ulit. Kasi ang magiging tanong ay, kung gagamitin mo yung maximum possible at saka maximum yung smallest possible, ano kaya yung ano doon? Yung accuracy ng sagot.
Hardest. Which one po?
Yung sa number 3. Tingnan mo yun, what if, kasi di ba, 28.3, let's say you arrived at that from round off and 53.7. So, yung measurement natin is actually between, yung length na yan would be 28 point something to 28 point something. Tapos yung length na 53.7 yan din. It's going to be between a range. Ano yung largest possible? Ano yung smallest possible? So, tingnan mo yung mga length. So, the lengths would be 28.3 yung isa. So, ano yung largest possible length? Na consistent with round off. Yung smallest is okay. So, ngayon, using those numbers, ano yung largest possible perimeter? Ano yung smallest possible perimeter? And 64.2. Tapos, teka. Let's see. So, 28. Tingnan ko yung smallest possible. 28.25 plus 52.65 times 2. So, 1.6. Huwag mo tayo mag-round off. Gusto ko na yung theoretical na na largest possible smallest. So, pag in-add mo yung smallest length at saka breadth, ang makukuha dyan, so 161.8. Okay. Ngayon, yung answer na nakuha mo kanina, isulat mo sa tabi para na ma-compare natin. One 164 at saka 160. So let's look at the values. At saka yung intermediate na hindi pa ni-round off yung 164. Okay. So, pag tingnan natin yung range, di ba? Medyo malaki rin yung range ng largest at smallest eh. So, it makes sense na mag-round off tayo dun sa digit na sa first, dun sa na mag-round off na maiwan lang ay tatlong digits. Di ba? Ngayon, yung 160, Di ba, plus or minus 5. So, pasok pa rin. So, 165 and 155 square meters. Okay. So, yung rule for getting yung best value, we won't talk about that yet. Okay? This just gives us some clues so that when we go to the rules, magmukhang reasonable siya. Ngayon, let's look at number 4. Sorry, maximum perimeter yan, no? Area. Kalimutan ko. Yung sa number 3. Yung addition kasi, mas simple yung largest possible at smallest possible eh. Area naman. So, largest possible area na consistent. Tapos, teka, bakit 53.7? Teka, gusto kong makita yung numbers mo. 1487, no? 28. Okay, 53.65, 28.25. So, yung check lang natin. 28.25 times 53.65. That's going to be 1515.6125. Okay. Tapos, yung rounded off at saka yung unrounded, yeah. Pansin mo yung range of possible values. 23, 1515, 1519. Tapos, ano yung binibigay ng round off to ano? So, yung rule na ginagamit ay round off so that you have the same digits as yung sa given. So, that means you have to round off to 3 digits. So, that gives us 115, 1519.71. Pag ni-round off natin, that's going to be 1520. Yeah. So, kung 3 digits. Pero ano yan eh, hindi man yun hiningi. Hiningi ay give your answer round off so that you only have to the nearest 100. So, kaya 1500 siya. Okay. Yung sa number 4 naman, okay, compare ko lang. So, teka. Saan yung number 4? Okay. Tapos yung ano, teka, pwedeng zoom in para makita ko yung okay, 4.9, 10, 11, at saka 6.49. Okay. Yung number 5, patingin. Teka, tabi natin yung question. Ay, eto. Sabi, okay lang. Sige, zoom in. Nakabukas naman yung book ko. So, okay lang. So, pag number 5, 1519, 5,192.3 is equal to 519.
Bro. Yun yung tawag.
Okay. Which is...
Yun yung unreasonable na answer.
Kasi ang laki na ng difference eh. 1/10 siya around 1/10 siya nung 5,192, di ba? So, walang sense na mag-drop off. Okay. So, ayan. Instead, kailangan mo talaga yung 0 para masabi na 5,000 something talaga siya. Actually, yung ano niyan, may counter mo dito yung bakit nagsa-scientific notation eh. Kasi yung idea dito, pag nag-scientific notation ka, obvious kung ano yung significant. Which we haven't talked about. We'll talk about significant figures next, diba? Ngayon, yung numbers, number 6, patingin. Okay. Tapos ni-round off natin to... Okay. Pag tingnan mo yung ano niyan, ano yung largest possible na pag ni-round off natin, magiging 5,077,000? So, for 5,077,000, so, ano yan, 499?
Opo, wait lang. Hindi ko siya nga-move.
Okay, so 9. That's 4 yan. Okay, so pag ni-round off yan, 7, okay, magiging 7. So it will stay 7. Tapos pagka 5,077,500 na, wala na. Hindi na pwede. Kasi that rounds off to 5,078,000. Okay.
Unless na may parang amputipon, so half yung katawan niya. So 577,499.5.
Ay, pero wala namang half people eh. So hindi siya hindi na kino-consider 'yon. Tapos walang so yung rounding off din actually, or yung largest possible, smallest possible, kailangan din you have to know how the number was obtained. What does it represent? Kasi here, hindi siya length na pwedeng mag-take on ng values na arbitrarily close to 5,077,500. Kaya 499. Okay, yung number 7 naman, Farhan says that 26.97 is equal to 27 when rounded off to one decimal place because he thinks that 27.0 is the same as 27. Do you agree with him?
Why?
So explain your answer. Okay, so if you round off, diba? Actually yung ano niya, it's not about precision. It's more about, are you actually saying what you mean? Kasi pag sinulat mo na 27, you mean na the number is between 27.5 and 26.5. While if you write down 27.0, you mean that the number is between this pair. So it's if you round off to one decimal place, kasi and that's there's a good reason for rounding off to that place. Iba yung information na kino-convey nung 27.0 sa 27. So, yan nga. Yan yung ranges eh. Okay, let's go to the next, yung sa 3.2. Tingnan mo yung tingnan mo yung hindi. Buksan mo yung book. Ano to eh, I think gusto ko yung yung discussion niya. So that, para lang tingnan mo yung start ng section 3.2. Okay, share ko yung book.
Ito
na lang.
Dito mo. Ano ka?
Hindi.
3.2? Lion, 3.2 po.
Okay. Tapos pa-share dun sa screen. Tapos kuha kang papel. Or kasi may mga tanong to eh, 'di ba?
Ito po.
Okay, so let's look at the book. Ang sinabi, tingnan mo yung scale. So Lee Sin and Kai Rule are asked to measure the volume of water in a cup using two different measuring cylinders. The readings are shown by figure 3.1. Ano to eh? So si Lee Sin, ang ginamit niya cylinder 1. Tapos si Kai Rule, ang ginamit niya
13.
cylinder 2.
0.1.
So, tingnan mo yung ano. So, yung ano niya, so, pag nag-report sila ng measurements, si Lisin justified yung pagsabi na 13.1 kasi pag tinignan mo na maigi yung scale ni Lisin, tumatapat sa 13.1. Pag tingnan mo yung same volume sa scale ni Kai Rule, not enough information to tell kung anong decimal, kung ano nasa first decimal place.
You can visually tell po that it is like over 1/2. It's literally parang over 1/2. Is it safe to say that it is 1/2?
Okay. Ngayon, ang tanong doon, pag sinabi mong, let's say nakita mo na mukhang in between, how accurate is that? So, medyo malaki yung ano eh. Kaya usually yung ginagawa, yung practice ay, if you record, usually kapag hindi mo nilalagyan ng ano, ng additional information. So, si Lizzie, ano ba, sinabi niya, effectively, ang sinasabi niya, the measured value is going to be between 13.15 and 13.05 cubic centimeter, which matches yung lumalabas. Si Kai Rule, he can't say that. Kasi yung scale, hindi nga maayos eh. Hanggang 13 and then 14. Pwede siya mag-estimate. Sige, 13, kung 13, neither to 13 versus 13.5. Pero yung uncertainty mo is about plus or minus 1/4. Nung scale. And kung hindi mo i-report ganon, then you err on the side of caution. Okay, my measuring instrument is only capable of reading 13.
Kung ano po, let's say malaki pa yung difference between 1 and 1 and 2. Tapos na nakita niyo po talaga, it really looks like in between. So then the will be big.
Ang assumption dito, hindi available yung cylinder 1. Meron ka lang cylinder 2.
Kaya nga po, if we think that, if Cairo po thinks that it is like 13.5, is it safer to just round it to 13.5 rather than be even less accurate by saying it is only 13?
I think pag ganyan, case to case na yan. Yung 13.5, okay, it's rounded off. Pero yung ano kasi niyan, pag nag-carry over mo sa calculations, ang hirap ng uncertainty analysis. Kasi plus or minus 2.5 yun eh. Versus kapag yung mga pag plus or minus 0.5 or powers 5 times 10 to the something. Yeah, it is possible. Pero minsan kasi, for example, what if yung isipin mo na, what if yung cylinder na what if yung cylinder, di ba may mga additional problems when you're doing this eh. Pag nag-measure ka ng liquid, may tinatawag na ano yan eh, hindi siya straight line.
Meniscus po.
Pag tingnan mo, di ba? May either it's going to curve upward, it's going to curve downwards, or pwedeng, baka may rare case na straight line siya. So you have to adjust for those things as well. I think justified din naman si Kai Rule na sabihin 13, pero it's really based on the accuracy available to him.
Opo.
At saka kasi the other thing is, pag pinasa mo yung records mo to someone else at di mo mapagtanungan si Kai Rule, pag sinulat niyang 13, at least may idea ka na malamang plus or minus yung accuracy is plus or minus 0.5. Versus kapag hindi mo alam na, for example, what if sinulat ni Kai Rule na, sige, nag-estimate siya 13.5 and then doesn't say anything more. Then, confusing yun for the reader kasi yung 13.5, nag-estimate na siya, akalain ng reader, that means yung number is between 13.55 and 13.45.
Well, actually po, he's not really sure if maybe it's in the bounds of the 13.5 and 13 yung ano.
Kasi baka ang binabasa niyang 13.5, 13.4 pala.
Opo. Out of the bound naman siya.
So it's safer to just leave it at kung ano yung kaya ng instrument na ganyan.
Opo.
Okay. So, ngayon, Leeson and Kai Rule have different answers. Diba? So, which is more accurate? Kung, we're talking about the same system. Diba?
Opo.
So, mas accurate yung magiging measurement ni Leeson kasi mas finer yung scales niya. Ngayon, the answer 13.1 cubic centimeters has 3 sig figs, while the answer 13 cm cube has 2 significant figures. Both figures are approximated to a different degree of accuracy as the values obtained are limited by the accuracy of the measuring instruments. Cylinder 2 can measure up to 1 cubic centimeter, while cylinder 1 can measure up to
limited by the accuracy of the measuring instruments. Hindi kaya po precision yun. Kasi let's say po yung mga Chinese na tape measure.
We'll talk about precision and accuracy. Actually, precision and accuracy are two different things.
Opo. Yun nga po.
Yung precision tells you, if you repeat the measurement many times, yung numbers mo ba halos pare-pareho or wala masyadong variation between your numbers? Yung accuracy, pag kinuha mo yung average ng measurements mo, ayos ba yung measurement mo ba is near the true value?
Opo.
So, different things sila eh. Yung idea kasi kapag bakit average, kasi yung idea, yung error is random. So, sometimes you're going to get something higher, sometimes you're going to get something lower, but eventually mag-wash out sila if you average. Or nagka-cancel sila during the averaging process. Ano yun? Babalikan natin yan. Pero for now, ito muna, sig figs muna.
And what if the instrument itself, it looks like it has more. Let's say po cylinder 1, it has more divisions. But it turns out the divisions themselves are wrong. So
ibang error naman 'yon. Kapag systematic error na 'yon, na mali yung divisions, halimbawa, stretched out by a factor. If you can adjust. Basta alam mo kung ano yung factor na 'yon. Kasi may mga scales na temperature dependent eh. Halimbawa, if you have a metal ruler, yung length ng isang ruler, ng isang metal na instrument, it gets longer when the temperature is higher, gets shorter when the temperature is lower. So, may mga
difference po, let's say, nasa summer, tsaka nasa amihan, tsaka there's a visible difference po.
Depende. Kung malaki yung length, for example, yung height ng building, may measurable difference yan eh kapag winter at saka summer.
Opo.
it's large enough so that it's measurable.
Opo.
So kung yung ruler mo ganon, may adjustment. Okay. So before I go into that, ano yan eh, pag-uusapan na yung mga possible errors sa lab. Yun. Ito muna yung ang purpose na dito, when you calculate, how much can you trust your calculation? Yun yung pinaka-goal natin dito. How much can you trust it? Tapos, gusto mo rin na if you calculate, yung reporting mo ng sagot mo, mapagkakatiwalaan din. Yeah. So, okay, let's look at the So significant figures are used to reflect the degree of accuracy. So a number is more accurate when it is given to a greater number of significant figures. Or actually it's more the experimenter who reports it thinks na kasi ultimately goes back to a person eh. The reporter believes that the number is this accurate.
Yung ano na po, yung perception na, yung nakita na po is he saw more significant figures. Na let's say someone who's may double vision siguro hindi na po makita masyado. But is it really accurate po? Kasi there's also accuracy na trueness po eh. So
ano yan? It's yung ano dyan ay yung significant figures reflect degrees of belief of the person who reports and calculates. So the person who's reporting this believes na it is this accurate. So ano yan? Kaya when you're reading a measurement, it's always sino gumawa ng measurement? Pagkakatiwalaan ba yung process niya? Di naman kasi 'di ba? A measurement is always made by someone who's human. And humans can make mistakes. Yung isang famous na measurement, yung charge ng electron. Si Millikan yung unang gumawa ng experiment. Tapos ang nangyari, precise measurement siya na yung nire-report niyang values ay yung uncertainty mas anliit. Yung mga tao na gumawa ng measurements after that, pansin, teka, may mali dun, hindi nag-agree yung measurements namin with Millikan. So, titingnan nila yung sarili nilang calculation at yung sariling measurements, mag-iisip, makahaps na ng reason kung bakit sa tingin nila yung higher value, kasi yung measured values nila slight higher than Millikan's value. So they go through, they think about ano may mga possible reasons bakit umakyat. And then they think, ito dahil dito. Tapos ang nangyari tuloy after thinking about that, yung measurement nila lumalapit sa measurement ni Millikan. But actually, it was discovered later, much later, na hindi pala may problema yung experiment ni Millikan. Merong inaccuracy na pumasok. So,
sa mismo po yung mali.
May mali talaga siya. Pero ano yan eh. So, magaling yung So, kaya hindi ano yun eh. Kaya yung experimental numbers, you can't really write them on stone. Kasi, there's always a possibility that someone made a mistake. Or at least may error na pushing the value to a certain direction. Okay, so let's go to the next one. Ang sasabi na naman yan, kaya ang tingin ko dyan, significant figures are a way for the reporter to express how much he believes in the answer. Or in the given number. Okay, so tingnan natin sa yung sa unang practice now. At saka, so practice now on page 65. Patingin ng sagot mo. Yung hindi yung rule 1 at saka rule 2 hindi yan kailangan pag-usapan yan. Titingnan ko na kung ano yung sagot mo. So, yung first question, number of significant figures. Okay. Tapos, using two different, which is more accurate. Okay. Yung wording lang, no? Kasi, yung sa physics, may specific meaning yung precise eh. Precise, parang darts. Yung analogy for precision ay, you throw darts, tapos most of your darts fall within a certain area. Precise yun.
Baka po yung
Pero,
kamay na po magaling sa tinatandaan niya po yung location. Pero it's not really on target, on yung actual na bullseye po.
It's more of nagka-cluster, clustering ng measurements yan eh. Precise means most of them cluster around a certain value. So kung darts, pwedeng hindi tumatama sa bullseye, pero most of them tumatama sa isang region.
Kunyari.
Okay. So, eto. May isang may web page na papakita ko. Yung darts analogy. Eto. Tingnan mo yung, share ko na lang yung page. Teka, send ko muna sa Facebook para pa yung tingnan mamaya rin. Tapos, share ko muna sa share ko yung screen ko. Yung
pero lang ko po yata nung 2008 ba po yan? Yung ISO ba? ISO 5725 yata po. Parang nagpinalitan na yata po na yung definition na precision and accuracy. Sir, baka muted lang.
Hello, sir. Hello,
sir.
Hello?
Hello, sir. Yes,
Ayan.
sir.
Sige. So, tingnan mo yung sa screen. Yung ginagamit na terminology, at least sa mga physicists, pag accuracy, yung how close a measurement is to the true or accepted value. Tapos yung isa, yung precision, how close the measurements are to each other. So, yung analogy dyan, darts. So, for example, tingnan mo yung sa letter B.
Precise.
Yung darts mostly nagla-land on around the same area. Yung average niya is going to be somewhere in the middle. So yung average yung titingnan natin to get a look at the accuracy. So dito, so yung numbers, iba yung scientific meaning sa everyday meaning. So dito, this is precise kasi most of them fall around the same area. It's not accurate kasi ang layo sa bullseye. Yung sa C, ang rin yan, yung middle niya, okay, nasa bullseye. Mukha namang nandyan. So this is accurate in the sense of the average is at the bullseye, pero yung precision niya, hindi sila nagka-cluster around the same, near together eh. Yung precision is bad. Yung letter A, yung average nila would be somewhere here. Wala sa bullseye.
Neither precise.
So neither precise nor accurate. Itong C, nakakatawa eh. Kasi makikita mo yung difference in meaning eh. So it's not precise, di ba? But it's accurate.
More accurate. Opo.
Di ba? Kasi yung average nandyan. Pero hindi yan yung usual meaning na accurate eh. Ang iniisip mo pag accurate, dapat lahat sila nasa bullseye eh. So we're talking about pag in-average out mo yung measurements.
Paano na nga nilata po ng 2008, ISO 5725 po? Parang pinalitan na po yung meaning.
Hindi, ganito. ISO is a standard setter for na people choose to accept voluntarily. Yung ang tanong kasi diyan ay, is it something that's accepted by this particular community? So kung sinusundan ng yung physics kasi hindi naman always sumusunod sa ISO standard eh. Kasi it's really a discipline dependent thing.
Opo.
So kaya ano yan. So kaya ang always, okay, may standard na ganyan, pero always when you're faced with, we have to find out kung yung standard, ask yung kung sino man yung kausap mo or sino man yung or anong discipline yung gumagamit ng standard.
Opo.
Okay. So stop sharing now. Tapos balik tayo dun sa dun sa ginagawa mo. So yung tinitingnan natin so far ay ito. So yung next na practice now, patingin. So number of significant figures. Nearest 10, 3. Nearest kilometer. Wait. To the nearest kilometer, 1, 2, 3, 4, 5.
Nearest kilometer. Not nearest 10.
Oo. So 5 yan. Actually, yung ano niyan eh. Yung reporting na, yung writing na ganyan, kailangan talaga importanteng information na hanggang saan ka nag-round off. Kasi pag sinulat mo yung, tingnan mo yan, yung balik tayo sa number ulit. Let's say sinulat mo yung number na yan. Yung 25,000 kilometers. If you don't specify yung saan ka nag-round off, hindi clear sa reader kung ano ibig sabihin yan. Plus or minus 500, plus or minus 50, plus or minus 5, or plus or minus 0.5. Walang ano eh. Kaya kita mo yung nilagyan lang ng to the nearest something. So, get later, so after we do yung chapter na to, we'll talk about scientific notation naman. Kasi it's a way to avoid yung ambiguity niyan. In scientific notation, pag sabi mong to the nearest kilometer, that's going to be reported as 2.5 times 10 to the 1, 2, 3, 4.
So yung ano na po, yung whatever is the before the 10 to the yun na po yung significant figures. Pero yung ano na mismo, yung you will avoid the ambiguity lang. Kung ganito po, baka yun pala, somehow, the measurement is almost exactly 2,500. Ay, 25,000. But it's just 25,001 kilometers. But then, baka siguro i-assume po na maybe this was rounded to the 1,000 because it seems so unlikely that it's true.
Pwede kasing sakto yan eh. Hindi naman i-specify kung ano yung kung hindi in-specify to the nearest kilometer. Di ba?
Opo.
Kasi, for example, yung 100, let's say may nag-report sa'yo, 100 centimeter, 100, no, hindi 100, 1,000 millimeters. Tapos hindi sinabi, ano yung accuracy nun? Tapos yung pala, yung ginamit yung mineasure niya, yung platinum iridium bar dun sa standards, sa Bureau of Standards. And that's going to be accurate up to the millimeter.
Opo.
Diba? Okay, so ito to the nearest 10,000.
Saka
Yung
baka pa pala platinum iridium yun para hindi po siya mag-corrode.
I think parang hindi siya mag-corrode. Tapos kept in a temperature and humidity controlled environment din siya.
Opo.
Yung yun yung old standard for the meter. Yung new speed of light based.
Opo.
Ito naman
Tsaka
po,
noong
paano-
2019, diba, nag-change na rin po yung kilogram, mga ano po, lahat naging constant base na po.
Okay, let's look at that. So, dito, to the nearest 10,000, that's two significant figures kasi yung 10, ina-assume dyan, sure tayo. Yung sa C. So that should be 2. Kung to the nearest 100,000, 1 sig fig.
Opo.
Yung sa letter C, tingnan mo.
1. Minus 10,000. Opo.
Yan. So dapat 2 yan.
Nato. Saka na po pala, kung ano po, kung meron po kayong balloon, how would you weigh it? Di kaya po lulutang yun?
Vacuum chamber. Yung medyo, yung ano.
Di kaya po sasabog yung balloon naman po. Malaki.
Kung we won't know until we try.
Opo. Pero totoo sila.
Okay.
Hindi siya, may weight na nandun po siya.
Kasi po nag-experiment po sila sa chemistry po, yung gases. So paano may problem? Walang
No apparat, no yung ganun lang. How do you
given lang.
How do you measure the pressure inside of a balloon? Isip ko po ideal gas law. So, syempre, nakakuha po lahat except yung mass, which needs to be, may balance po kami pero hindi analytical. Paano po i-weigh yun na accurately?
Para nagka-discrepancy po kung ifa-follow lang yung formula. Pero siguro
sobrang baba po ng pressure kung ano naman.
Hindi ko alam yung exact setup eh. So, kailangan ko makita yung setup, ano yung available na instruments, and then I can make a guess.
Opo.
Pero, yun, yung first thing is vacuum chamber.
Wow.
At saka ano ba yung mga questions ay ano ba yung pwede allowed na gawin sa balloon? Okay lang ba na sirain yung balloon?
Opo.
Kasi kung ganon, di vacuum chamber, tapos
Yung gas na po, yung anin.
well, mahirap pa rin no? Ano ba?
Kasi po parang nung mini-measure po na, yung mass, nung mini-measure na yung mass, parang kahit na walang electric fan, kahit na wala po, parang lumulutang pa rin doon sa na digital balance, kahit na paano.
Baka kasi ang gagawin ko yan, ilulublog sa tubig. Tapos may mass na enough para lumubog yung balloon plus yung nakasabit na mass. Tapos i-weigh ko sa ilalim underwater.
Genius. Oo nga po na. Kasi siya sa tubig eh. Pero baka masira kaya po yung balance naman. Hindi, theoretically, kung i-say
yes.
waterproof yung balance, pwede. Nasa tubig. Opo.
At saka depende kasi, how accurate
Yung places
mo.
po.
So, yan. Kaya kailangan pag-eksperimento mo siya eh. It's not enough to just guess eh. You have to fiddle with it and find out experimentally.
Opo.
Okay, tingnan ano to? Teka, so number of significant figures of the following. Tapos, yung importanteng mapag-usapan ay yung kay Ethan measures the piece of wood. Tingnan mo tong yung discussion niya here. So, balik tayo sa book.
First Ethan. Okay.
Tingnan natin yung discussion. Yung just before, yung Ethan measures, tingnan mo yung discussion.
Where is it? Dito.
So, pa-share on your screen. Yeah. Yung Ethan measures the piece of wood using 2 different rulers. So, yung measured length ng isang ruler, 0.6. Kasi din mo yung scale. Yung isa naman, 0.60. Kasi mas accurate mas maraming divisions yan eh. Ngayon, tingnan mo yung sa baba. So, let's move further down. Which measurement is accurate? Or more accurate?
B po.
0.6 or 0.60?
0.60 po.
0.60. Ngayon, based on the intervals in both rulers, 0.60 is more accurate. This is because 0.60 meters is measured to 2 significant figures. While 0.6 is measured to how many significant figures?
1.
1. So in decimal, all zeros after a non-zero digit are significant. Okay. So it tells us something about, kaya kita mo yung mga may extra zeros dyan. Kasi it's a way of signaling we were able to measure up to this. Ngayon, yung before zero, yun yung next, yun yung yung paano yung 0.60? Is the zero significant before 0.6? So itong yung kasunod, yung Raj measures the length of a piece of string and finds it to be 5.7 cm. So connect to 2 significant figures. Converts it into meters and obtains 0.057 meters.
So this is why the place value holders fall before the actual non-zero digit. Yung
hindi sila counted.
Significant. Kaya pala po, I always thought, but why are the zeros after the, let's say po 45,000? Then why are they significant if these aren't significant? So ito po pala po. So you can just convert it into something that has none of those leading zeros, and then thus mawala po yung significant figures, which is not supposed to happen.
Oo. Kasi, di ba, yung digits, significant figures are digits that you can trust.
Opo.
Ayan. So conversions should not change the number of significant digits. Kaya, all zeros before a non-zero digit are not significant. Kaya ko to pinoint out kasi pag only by working this out, nakikita mo yung bakit ganun yung rule. Diba?
Opo.
Okay, so yung after that, yung eto. So, yung practice, eto, may additional question pa ako. So, may practice na ako kasi na, teka, so move up first kasi mukhang na-miss kong pag-usapan yung practice now. Ayan. Ngayon, patingin ang sagot mo dyan. State the number of significant figures of each of the following. .0 dapat yung may 0.10 no, nasaan yun?
0.10.
Parang nawala.
Wait lang po. Where is it? Okay, it's gone. Okay.
Sige. So, sige, sabihin mo lang sa akin, yung sa letter A, ilang significant figures yan?
2, 3,
Okay.
6.
Yung sa B?
2, 3, 3 po.
Okay, and then
6.
and then 4. Tapos, yung number 2, a line segment is measured using two different
Ay, ito pala po
instruments.
yun.
Ganun pala nilagay. Ano ba yan? Hindi mo pala nilagay.
Ito pa pala.
Yan. Okay, so which is more accurate and why? So may assumption tayo dito no na yung reporter ng values na yan, ginagamit yung rules for significant figures din.
About sa assumption po that the tools are not wrong.
Okay, so which is more accurate and why? Hello?
Abo.
So yung number 2, ano yung more accurate?
4.10 po. Dito po.
4.10. O sige. And yung additional question, ito. Teka. Isulat ko, tapos i-share ko.
Saan po? Facebook?
Sa Messenger na lang. Ito. Para mabuksan mo. So, nasa Messenger na. Sinend ko.
What? It went somewhere po. Ayun.
Okay, so a ruler with a millimeter scale measures the length to be 40 millimeters. If this measurement is to be recorded in cm, how should it be written in your lab notebook?
My lab notebook. Oh, okay. Ruler person. Paste. Additional question. Something. A ruler with the millimeters. To be for, okay. Measure is to be measured in cm. Point 40 centimeters po?
Teka, ilang centimeters pa sa isang millimeter? O ilang millimeters sa isang centimeter?
10.
10. So, kung 40 millimeters,
4.0.
4.0. Okay.
Nabaliktad ko.
Bakit? Okay, sige. So, it should be 4.0. Kasi, dapat pag nag-convert ka ng units, it should be the same accuracy. Ngayon, yung next na, so baba tayo. Tingnan natin yung next na item. Sa book. So, move down. Para lang...
Naka-share ba po yung book all this time? Patay. Kala ko pa na-share ko po yung Jamboard.
Okay. So, yung next ay state the number of significant... So, state the number of significant figures of each of the following. Yung sa letter A.
Ito mo.
Yan. So, 2, 3, 3, 1, 2, 3, 4. Okay. Ngayon, bago tayo pumunta sa next na sa practice now 4, basahin natin yung text. So, paki-share nung book ulit. Yan. So, how many significant figures does 7,500 have? The number 7,500 has two significant figures, sabi ni Michael. Si Devi, sabi naman, no, the number 7,500 is three significant figures. The teacher says that both Michael and Devi are correct.
What?
Why is this so? Actually, ayoko ng ganong yung sasabihin, both are correct eh. Context dependent siya eh. Pero sige, tingnan natin. To answer this question, let's consider the number 7498. Correct? So, round off this number to the nearest 100.
7,500.
So 7,500. Correct to the nearest 10 or round off to the nearest 10.
Still 7,500 po because the 9 carries over.
So 7,500 has how many significant figures if it is correct to the nearest 100?
2.
Okay. Tapos, how many significant figures if it is correct to the nearest 10?
3 significant figures po.
Okay. So, in whole numbers, the zeros at the end may or may not be significant. It depends on how the numbers are approximated. Kasi, ang problema mo sa pag nag-specify tayo ng rule dito, walang uniformly accepted rule eh. For pag ganyan. Pag sinuot mo 7,500, nalala ko yung isang rule na pinilit sa amin dati, lagyan mo ng decimal point para naka-indicate na lahat ng zeros significant. Paano kapag halimbawa 3 sig fig pala siya or 2 sig fig lang? Paano na? Scientific notation, okay, wala ka ng problema kasi
Otherwise po, you really have to significant do something.
you have to say and write it down. So, kaya kita mo yung sa practice now, state the number of significant figures in each of the following. So, if this is correct to the nearest meter, ilang sig figs yan?
No po.
Diba? Or to the nearest 10 meters. Ito, yung sa letter A, ano yung sagot mo dyan?
Let's see. Oh no, where is it? Me. Ano po kasi yun? Practice na pala yun.
Oo. Wala siyang ano eh.
Ito po yung
Para ma-distinguish sila, lagyan mo ng page number tapos wala.
Ito nga po yun.
Okay. So, ganyan, no? So, may round off. Ngayon, let's move forward dun sa book. So, okay na yan. So, ito, yung worked example na nandito is rounding off to a required number of significant figures. I think may experience ka naman dyan. So, gusto ko lang tingnan yung sagot mo na sa practice now.
Finally, practice now with numbers. Why did they omit the numbers po? Why can't they just put practice now 3 something, 3A, 3B something?
I think nung final editing nakalimutan nila.
Bro.
Kasi ang confusing, di ba? Okay, ito. So, round off to 3 sig fig. Tapos...
What are the brackets po? Parentheses?
British English kasi.
Bro.
So, 3 sig fig. 1, 2, 3. Okay. Tapos, 4 sig fig. 1, 2, 3, 4. 4, 7, 10. Teka. Kung to 4 significant figures yan, dapat yung digits after yung 47, yung sa letter B, it should be 0.004710. Tapos wala nang dalawa. Oo.
Wala na tong huli.
Kasi hindi may ano na yun eh. It's claiming to be more accurate than it really is. Okay, 4971, if we round off to 2 significant figures, ang katabi ng 9 is 7, no? So okay. Yan. Ngayon, tingnan natin sa letter D.
Letter D.
Pag-isipan mo uli yan kasi hindi tama yan.
Yes,
So 2 and then okay. Ayan, let's go further down. Yung yung solution dito, correct to 3 is equal to 67,000 correct to 3 significant figures. So, ano yung range ng so to get x equals kasi di ba, ang requirement natin pag ni-round off lalabas na 67,100. So dapat ang x is greater than okay. So it's going to be greater than 5. Tapos and then from here trial and error na, no?
No po.
Okay, so x equals 8. Yung next, tingnan natin.
Hinanap ko na lang po sa catalog.
Yeah, check ko yung yung so rounding off and then ayan. Ay, sorry, balik tayo sa book.
Okay.
May part dito na dapat na pag-usapan. So, tingnan mo yung investigation on page 68.
Suppose 215 students and something are going to a pass that can be something. Okay. So yeah. 220 people, yes. Divided by 30, so 7 and there's a remainder. So but naguto. 7 and so 8 buses. 8 buses ba or pwede na lang po sila pagkasyan sa roof.
Yeah.
8
sorry. 220. So ano yan? 220 divided by 30, di ba? Tapos ang lumalabas na number 7.333. Di ba? Pag sa calculate mo.
Po, either a new bus or maybe pag-standing na lang po sila.
Okay, so syempre assumption natin, no, hindi bawal tumayo. So ilang buses 'yan?
8 po. Pero sayang naman po.
Ngayon. Pero pansin mo, yung sagot is not
po kayo ng isa pang bus. Pwede lang.
I think yung point dito ay, tingnan mo, yung sagot ng calculator 7.3. Pag nag-round off tayo, anong sagot?
Sa 8. Then 7. Minsan kailangan po more. Yung ganun pa yung point niya.
Oo, na yung pag gumamit ka lang ng rounding off without thinking, you are not going to get the correct answer.
Aba. Parang ano pa yung nakalimutan ko po yung scenario rin na ganyan eh. Parang yung you will divide number of people into some number of groups. Ito bang it's the exact same scenario. You'll divide some number of people into some number of groups. Hindi naman po sila there cannot be a fraction of a people unless na may mangyari sa kanila. So dapat you will give them one more for yung mga leftovers na tao. So you will round up always default.
So you don't always round off. You don't always follow yung rounding off rules ng basta-basta without thinking about context. For this one, nagfe-fail yung rounding off eh. Tignan mo yung scenario 2. Suppose you're the designer of a lift that can carry a maximum mass of 897 kilograms. However, kasi di ba pag meron yung lift elevator. So a lift that can carry a maximum mass of 897 kilograms. However,
so basically holds 1 ton po. Ay less than something ton.
However, so ang tanong dito, kasi gusto mong maglalagay ng warning sign. Ito yung maximum capacity. However, you're told to put the maximum mass correct to the nearest 100 kilograms. So let's say nasa warning sign. Warning. Maximum mass allowed is
800.
This to the nearest 100.
So yung scenario 1 po, always round up. Ito naman po, always round down kasi delikado ko more.
Oo. Diba? Wala kang allowance for Tapos, yung tingnan mo, yung last scenario, yung sometimes in real life, you have to round off to the nearest 5 cents. But not to the nearest cent.
Describe situation. When the BDO does not give you the 1 centavo coin, so therefore you're forced to live with the 5 centavos only.
Diba? So, kaya yung nangyayari niyan binibigay 5 cents. Tapos, hindi ako sure kung ano yung rule na ginagamit ng SM na paano kapag yung change 1 centavo? Ano magsusukli ba
Exact
sila?
Parang yung video
Or
nga.
will they round? Or wala? Diba? Pero may mga ganyan yung choice of magsusukli ka ba or hindi. Diba? That's actually one example of this one.
Opo.
Kung may 5 centavo coins like SM hypermarket, pero walang parang wala na akong nakikitang 1 centavo, wala talagang 1 centavo coins for the longest time Parang last yata na
Ako po meron ako 1 centavo coin pero dalawa lang yata po, yung isa nawala. Ganun ka-rare po yun pero still in minting daw po sila. I don't get it. Yung sa ano po sa US, sa US nga po sa gasolinahan kasi kay may up to 1,000. May meal po sila parang wooden token. Pero I don't see the point and use of using it kasi that's so little. 10 of those 1 cent lang naman po, di ba?
Okay. Anyway, let's go to the next thing. Yung sa book, yung rounding and truncation errors. Ano to share ko naman. So, tingnan natin So, non-exact answers and intermediate steps. Tapos, FX991, yung FX991EX mo ba nandyan? Kailangan natin
Yung classmates po. Ganda po.
Okay. Sige. So, if we write all the digits for non-exact answers, square root of 131, the working will look messy. So, in order for the final answer to be accurate to say 3 significant figures, any intermediate working must be correct to 4 significant figures. So, can you explain why? Actually, ano yan yung can you explain why yan gusto mong mabawasan lang yung rounding, yung error introduced due to rounding off. Yun lang.
Yung classic example po yata dito yung rounding error. Alam ko po is with percentages. Parang yung ano nga po, recently, yung sa ano po, yung sa chemistry nga po, ginawa ko po yung ano ng air, what's the composition of air. So, renown po nila to the first decimal point. Not really to a significant figure, basta yung first decimal point mo. So, pag sama-sama niyo po is only 99.9. Nawala yung mga iba po. Hindi siya complete.
Actually, dito may may example din na ipapakita
Opo.
So, ang concern natin dito is rounding off and truncation error. So, tingnan natin investigation.
It's the exact same one. It's the exact same thing. So, yung...
Ayan. So, anong nangyari dun sa missing 0.1% of the votes?
Kasi...
Hindi, gawa ka i-calculate mo kaya. Copy the table. Tapos naman, isulat mo yung mga numbers na without rounding off.
So, 187 over 300 set to A, 0.623333 sige. So, 62 and 1/3, okay. 2 over 300, 0.17 and a third din. Yung isa naman, 20 and a third. So yung mga third na po yun will so dito po the 0.3% all became 9%, but in reality it should become 9.99999%, which is 1%.
And actually yung 1/3 siya, di ba?
Opo, 1 po
so,
yan.
So magiging 1 siya pag inad. Hindi na namin ma-represent kasi fine yung decimal representation niya infinite na na recurring So dito may rounding off error. Ngayon tingnan mo yung tinatanong dito. So given that there is a new member who voted for Vishal, calculate the percentage of votes. Kuha kang table, kopyahin mo to. Tapos what if dagdagan mo ng +1 yung voters ni Vishal?
Sige,
what happens to the percentage?
188 over 300.
Do it on your note, ano tawag dito? On the Google Doc, pa-share. So, copyhin mo tong table na to. Copy and paste. Para matingnan mo habang ginagawa. At saka para makita ko yung table na ginagawa mo. So, new page.
So this will become 300.
Go to make a new page. Kasi i-extend natin yung table eh.
Oh no. Siguro, wait. Ayan ang kala po, I will recycle a page. Where is it? So, yeah. Saan na? Cycle.
Or gawa kang separate na Google Doc. Okay naman eh. Treat it as scratch.
Clearing. Ayun. So this one will go somewhere here. Where are we? Dito. Ayun. Bagong meeting eh.
Naputol na ulit.
Naputol.
Okay. So, ngayon, tingnan mo yung 187 magiging. So, ngayon, kahit nasulatan mo lang siya, use red.
Ito, para
Hindi. Kaya gusto ko na i-ano mo yan kasi para ma-compare natin later yung values. So, sa katabi, so ang total magiging 301. Tapos yung kay visual magiging 188. And then, ano yung percentages?
To the ano pong percentage?
So, kung kung first decimal place lang.
Truncation or rounding? Round ko na ba?
Sige. $61 divided by 301. 20.3. Tapos pag in-add mo yan,
for easy.
ba?
So now there's a ghost who voted.
Na ano eh, talagang kasi it's actually still just an example of round follow through error. So it's possible na kaya yung ano yun eh. So it's actually possible na your computation can be either too low or too high, which is really the point of this investigation. Tapos balik tayo sa text. Tingnan mo yung remedy dyan.
The remedy, given there's a new number, okay, blah blah blah. Follow through error, okay, nice. Rounding error, therefore the something can only be.
So, wag muna. So, tingnan natin. If we want the final answer to be correct to 3 significant figures, the values in the intermediate steps should be given to 4 significant figures. Thus, we will have, and then we round off. So, example siya na pag intermediate steps, use more digits. And then, at the end, round off. Kaya yung safe, yung relatively safe yung do all your calculations using the calculator. Kasi, para yung mga digits na nandyan, hindi ma-round off. Or yung rounding off, mas marami kang digits na na-retain. Hello?
Aba.
Yes,
So yun yung yun lang yung reason bakit yung na plug in everything into the calculator tapos don't round off. Ngayon, let's go to the next thing. So dito, so yung sa thinking time ulit. The population of city A. Ngayon, ito, medyo language game siya. Pag sabing approximately 2.5 million, what do we normally mean by that?
Mga like in the approximately 2.5, it could be rounding up or rounding down eh.
Hindi, yung normal usage ng pag nagbabasa ka ng news. Tapos nakita mo sa newspaper.
Rather close to 2.5. Kung 2.6 million po, they would not put it as 2.5. They would put it as 2.6. Parang 2.47 seems more, parang the news will change it to 2.5 so it was easier to read. Pero it's not really that far naman po from 2.5. Kung 2.45, I don't think na gagawin nila ng 2.5 yun.
Actually, yan eh. Yung, for example, nag-approximate ka. Kung 2.3, 2.5, 2.6, tapos, okay. Alam mo yung sa yung, di ba yung, kapag yung scale mo hanggang yung 1 centimeter, 2 centimeter, tapos wala kang millimeter scale, tapos sabi yung mag-approximate na yung 1/2. Parang ganun yan eh.
By eyeball.
Parang ina-eyeball mo na, okay, it could be 2.6 or it could be 2.7, pero sige, best guess, 2.5.
Aba.
So, pag ganyan, yun lang, I think yun yung interpretation ko ng ginagawa na approximately. So, in that case, yung parts 1 and 2, pwede. Pag ganun yung meaning. Na 2.6, okay, I can treat it as 2.5. 2.4, I'll treat it as 2.5. Pero sa part 2, pag may sig-fig rules ka na, mas specific yung meaning. 2.47, if you round off, comes out as 2.5 to two significant figures. 2.6 is not the same as 2.5 million to 2 sig fig. Magkaiba na sila. Versus, pag normal usage, yung 2.47, 2.6, pwede mong i-hand wave na, that's around 2.5 million.
Aba.
No? So, that means, normal usage may difference. Mas ano yan eh, mas tawag dito, mas specific yung meaning ng equal to 2.5 million to 2 sig fig. Talagang it's plus or minus something. Okay, now let's go to the next thing. Yung worked example, let's look at worked example 5. I think interesting din yung niyan eh. Yung writing niya eh. Yung the area of a square, if you take the square root, di ba, lumalabas na, ang ginawa niya, diretso siya sa, look at the digits, round off, para maging 11 point. To 3 sig fig, teka, check ko yung square, calculate natin. Square root of 131, ang makukuha niyan ay 11.4455 something eh. Tapos, ni-record as 11.4 to 3 significant figures kasi yung katabing digit 4. Pag sinulat niya yung 11.45, tapos kasi di ba, pwede siyang 11.45 pag nag-round off ka sa second decimal place. Tapos pag nag-round off ka uli, yan, magiging 11 point, pwedeng maging 11.5 na yung ganong mag-round off ka ng 2 beses, problematic. That's why you don't write it down that way. Kasi pag ganyan, sinulat mo 11.45, that suggests maybe you should round off to 11.5 and not 11.4. Diba? So, confusing din eh. Yung sa perimeter, so 4 digits yung, pag kinalculate mo yung perimeter ng square, in-include, siya. Yung ginamit niyang length of the square, yung length ng square or yung length ng side 11.45. Nagtago siya ng extra digits. Hindi niya basta-basta sinalpak lang yung 11.4. Nag-round off siya at the next digit so that may more digits than yung final answer. Kaya 45.8. Kasi kung 11.4 lang times 3, ang makukuha ang answer ay 34. 11.4 times 4, ang makukuha ang sagot 45.6. So, mas pangit yung quality ng sagot kasi affected by round off. That's why we have to keep an extra digit. Okay, so ngayon puntahan natin yung investigation. Yung next page. Sorry. Before that, yung practice na nga pala, tingnan ko rin. So yung sagot mo dito.
Oh no. Dito. Ayan. Ay. Where is it? 5.
Okay. So, yung square root of 105. So, if we get and then find the length. So, 2 into 3 significant figures, it's 10.2. Yung perimeter, so 4 square root of 105. Pag ginawa mo yan, na diniretso mo sa calculus of 4 times square root of 105, yung square root of 105 will have 13 digits. So, pag 13 digits times 4 at nag-round off ka, lalabas na 41. Ngayon, kung hindi mo ginawa yon, for example, ginamit mo yung 10.2, 4 times 10.2. Ang makukuha mo sagot ay 40.8, which is less accurate. Kaya yung kaya ano yan eh, kaya if you want to use yung previous answer, you make sure na you have more digits before you plug it into the next. So, ito, reporting siya na to 3 significant figures, it's this. But if you need it for the next calculation, you have to keep more digits. Kasi, for example, what if may mahaba kang sequence of calculations? Something from A is needed for B. Something from B is needed for C. Something from C is needed for D. Tapos A to Z yan. Tapos nagra-round off ka every time. Yung sagot mo sa dulo, medyo malabo nang maging accurate. Kasi nagpa-pile up yung errors. Okay, now let's look at yung sa investigation. Kasi yung investigation talks about yung limits ng ating calculator. So let's go to the next page, yung investigation. Sa rounding and truncation errors in calculators. So this activity may vary. So for our calculator, tingnan mo yung square root of 162. Tapos i-display mo sa decimal. So at isulat mo yung nakuha mong digits.
Hanggang 06 po.
Hanggang 06. Ngayon, isubtract mo kaya yung 12.727 92206 from that answer.
May negative 1.3578 times 10 to the negative 9.
So, actually, yung calculator natin, to get that answer, ibig sabihin, yung calculator natin has more digits than it actually displays. Diba?
Then why does it display most of the what can fit on the screen?
Ano eh, kung halimbawa, ano yan eh, I think yung conventional kasi na 10 digits yung ni-display eh.
No ba?
Even though yung figures natin dito, 13. Tapos, usually hindi mo kailangan yung ganyang accuracy eh. Yung for a lot of calculations, kahit na let's say mga 4 sig fig, 5 sig fig, okay ka na eh. So medyo overkill na yung 10. Kaya nga yung depende sa calculator, some calculators will not have 135. Yung iba nagsastop sa 1, yung iba nagsastop sa 3, yung iba nagsastop sa 6. So yung extra digits na yan, depende sa calculator. So yung first, if you buy a calculator, you can test, do this, subtract, so that you know ilang digits talaga yung tinatago ng calci mo. So, yung mga yung instructions dito sa A1, 2, 3 is actually just this para makita ilang digits. And so, our calculator is actually storing 13 digits. Ngayon, tingnan mo yung square root of 162. Now, square root of 162 is 12.727, 922, 0614, 061357,855, ... This was obtained in using a more accurate method than our scientific calculator. Pansin mo na yung 135 meron tayo. Tapos yung kasunod na digit which is 7, di ba pag nag-rounding off rules tayo, dapat 136 yan. Pero ang nakuha natin, 135.
So, tinanggal nila. Diba?
So, ang ginawa ng calculator natin, nag-truncate.
No,
yung next digit, tinanggal lang. Hindi siya nag-round off. Okay. So, if you get 6135, di ba? Our calculator truncates the value of square root of 162 at the 13th digit instead of rounding off to 12.727,922,06136. Kasi 35 yung last digit natin eh. Next, yung rounding or yung next part, yung rounding or check ko kung So, baba ka uli. Kasi nandun na tayo eh. So, move down the page. Yung rounding or truncation errors can result in ridiculous results. Tinry ko to eh. So, just so you can see. Take the square root. Ito yung instead of 7 times, if you keep getting the square root of 7, what will happen?
It will turn into 1 po.
Yung 1, di ba?
Ito po yung pinapahit ko sa kanya po. Pag there will come a point where it will become 1.0000 something 1. And then you do it again, it turns to 1. But then when you square, it will turn to 1.000001.
Diba? Hindi siya, So, every time, pag dumami yung square roots natin, hindi natin ma-reverse hindi natin ma-reverse. So dito, sa ibang calculators, take the square root 4 times and then the result you square 4 times again. You kuha 6.99999. Yung at least yun nandyan. For our calculator, mas kaya ng calculator pa natin yung 4 times eh. So, subukan mo ay take the square root 15 times.
7. Almost 1 but not yet.
So, if you keep taking the square root, and then square root answer, and then equal, paulit-ulit yan until umabot ka ng 1.000, 4 zeros before the next digit. So 1 point and then 4 zeros and then 5. So, nakuha mo ba na after so many square roots, lumalabas 1.000059386?
4 lang po, saka 7.
Square root ulit. So, gusto ko na may 4 zeros.
7.
So, square root of 7 and then equals and then square root of answer. Keep pressing equals.
59386 po.
So 1.000059386. Ngayon, i-square mo naman yan. So, tapos equals. Tapos paulit-ulitin mo siya hanggang tingnan kung makakabalik tayo sa
Hindi po.
makakabalik tayo sa 7. Hindi, di ba?
6.99999999875.
Oo, di ba? So, pero ano yan eh, unlike yung mga less powerful calculators, mas marami tayong beses pwede mag-square root na bumabalik siya sa 7. Ito kasi, yung example na binigay niya, yung calculator sa pinapagamit, take the square root of 7 4 times and then square it 4 times. Hindi na bumabalik sa 7 eh. So that means less digits yung tinatago ng calculator na yan.
Tinry ko po actually hanggang limit niya naging 1 na po talaga siya. Yung lumabas
pag
po,
nag-1,
ko po 6.92 na lang.
Ano yan eh, pag inulit-ulit mo yung square root, eventually magko-converge yan to 1 eh.
Nabo.
So, after so many times. And then, pag nangyari na yun, pag in-square mo, wala na. 1 na lang siya.
Nabo.
Okay, so, example yan ng, so this is an example of truncation error. Kasi, when our calculator does operations, hindi niya kayang itago yung infinite digits. Hanggang 13 digits lang yung kaya niyang i-save.
Nabo.
Ngayon, isa pang example ng yung mga difficulties and perils of significant figures. Ito. So, let me share my screen. Window. And then Scratch. For example, may numbers ka na 3.972135. Tapos, isasubtract mo yung 3.9. So, pag nag-add tayo ng dalawang numbers, so let's say in-add na sa 4.171895. Ilang sig-fig yung result? So plus 4.171895.
Lahat po sila still intact.
So intact siya, di ba? So if you're adding na positive numbers, 814403, pag ginalculator mo yan, ang lalabas 8.14403.
Nabo.
Pero yung given, 5 sig-fig. What happened? Ilang sig-fig ba talaga dapat yung sagot?
6.
So, sure tayo na 5 plus 5 is 10 eh. So, dapat 7. Pero yung display lang ng calculate natin, 6. So, something to think about then. Na pag may 0, yung calculate natin after the decimal point, you have to know saan ka mag-round off. Kasi kung may ganitong klaseng coincidence, you're actually dropping figures na significant.
Nabo.
Okay, ngayon, ito naman. This is for addition. Subtraction. Let's say measurements ka, 972,135. Tapos mag-subtract ako ng 3.972132. Ilang significant figures yung sagot?
1.
So, yeah. So ang sagot ay 0.000003, di ba? Which is 1 sig fig. This is how many? 1, 2, 3, 4, 5, 6, 7. 7 sig fig. So a calculation involving numbers with 7 significant figures gives us a result that's only accurate to one ng isang digit.
Opo.
Diba? Hindi siya tulad ng ano eh. So, yung rule of thumb na basta yung lahat ng numbers na binigay, let's say 4 significant fig, 3 sig fig or 4 sig fig yung given. And then you calculate. And then rule of thumb, yung result is 4 sig fig din. That's actually not always true. May mga possible calculations na nawawalan ka ng significant figures. And some of these examples include yung ang tawag dito subtractive cancellation.
Opo.
Na a calculation gives us a less accurate number. Ayan. Yung sa ano, okay, ito ba, isa pang one other thing na hindi pa napag-usapan sa book. Yung so far, ang nakita natin yung maximum possible product at saka minimum possible product. Kung halimbawa, ang numbers natin 3.46 at 7.53. Kung gusto natin kunin yung maximum possible product, yeah. Sige, 7.53 times 3.46. Okay. So, yung maximum product, sige, 7.53535 times 3.465, that's going to be, without rounding off, ang makukuha ang sagot using our calculator is 108,775. Ito yung max. Yung minimum possible is 72.53, 52.525 times 3.455. Kasi to round off to 6, ang makukuha nating possible value is 250.573875. Tapos, yung value without 7.53 times 3.46, ang makukuha natin, pag eto lang, ito yung minimum, we get 26.0538. So, yung rule of thumb na ginagamit dito, to get the maximum product of two positive numbers, just multiply the maximum of each factor. Paano kapag quotient? What if ang pinapa-compute sa'yo 7.53 over 3.46? Ngayon, pag pinlog in natin yan, ang bibigay na sagot ng calcu ay 2.176300578. Yan yung ano. So hindi pa ito yung gusto natin kunan na quotient. So using the largest possible numerator, smallest possible numerator, and denominators, what is the maximum possible quotient? Nangyayari ito. Maximum quotient at saka minimum quotient na consistent with these numbers.
Maximum 7.535 over
Okay, pwedeng pa-share nung computation na ginawa mo.
Yung ano na po, 7.535 tsaka 3.465.
tingnan ko yan.
535.
So, ito, 7.535 divided by
3.465.
yung minimum quotient, ano naman?
7.525 over 3.455.
Okay. Actually, mali yan. Alam kung bakit?
Bakit ba?
Yung maximum quotient is maximum numerator divided by minimum denominator.
I forgot. Okay, saka yung minimum over maximum para yes. Oo nga po.
Diba?
So dapat
So,
5
ganun din yung
over 5 over 5.5 tsaka 5.25 over 6.5.
3.465. So, ito yung these are what you have to use. Ano yan eh? Pero in practice, mahirap talaga i-track yan. Yung anong effect na, anong maximum possible, anong minimum possible. So, may mga ways to get around having to do this. Pero we'll talk about that later. Yung the most primitive way of tracking ano yung yung uncertainty is by calculating ano yung maximum possible value, ano yung minimum possible value. So, may mga instances na may formula. May function ka of x, y. Tapos bibigay sa yung numbers na x and y. Na may significant figures. And then you're asked to compute. Ano yung largest possible value ng f? Ano yung smallest possible value ng f? So medyo you have to fiddle around, especially if the function is complicated. Pero we'll talk about that later. It's just na yung computation and making sure that the numbers that you produce are accurate up to certain digits is actually a separate problem in its own right. Ang tawag sa domain na nagtatrabaho sa ganyang area, yung mga yung mga gumagawa ng numerical analysis, what they do is they develop algorithms for producing numbers.
Pi? Parang ganun po?
Numbers to the desired accuracy.
How do they find out? Kasi nga po yung pi. How do they know na, this is this? Do they use some sort of arithmetic series or something para to produce the
Usually, yung mga methods na ganyan, usually iteration Iteration and series.
Kaya nga po, how do they know na to iterate this and that? Do they have some sort of parang series nga po, arithmetic series to iterate?
Hindi ko lang alam. Meron sa they have figured out ways to calculate this, and they've proven na they do this to the desired accuracy. Pero yung specific algorithms, hindi ko alam kasi it's much out, ang layo na siya mula sa kung ano pinag-aaralan ko eh.
Abo.
Pero it's just doing this can use up all of your time already. Yung i-figure out mo lang yung if you do a computation and you want to make sure na it gives you accurate answers. For example, yung the weather. Yung mga models na ginagamit natin for studying the weather, those are actually numerically based. We make measurements and then we plug it into a computer. And then yung making sure that your computer gives you numbers that make sense. You actually have to think about ano yung mga errors na i-introduce kasi nag-round off tayo. How long can we trust the prediction?
Abo.
May yan eh. Yung how long can we trust the prediction ang sabi I think yung naalala ko na kwento ay up to a week or up to a few weeks. And then after that, wala na. Nawawash out na ng inaccuracies nung errors yung result nila. And they have to make measurements again, plug it into the computer model, and then do the same thing all over again. Okay, anyway, let me stop. So let me stop. Pero ano yan? So kaya siya importante. Parang ito yung mga first steps towards doing that kind of problem Na yung how do we know or how much can we trust a given calculation? Kasi for example, kung nagka-calculate ka and you're not thinking about these errors, common mistake yan sa nakikita sa university plug in sa calculator tapos ang ibibigay ng sagot 10 digits. Mali na yun, di ba? Kasi if you put in the 10 digits at yung given mo 4 digits lang, hindi na mapagkakatiwalaan yung ibang digits mo So you're actually not being in some it's actually you're not actually more of honesty rin yun You have to make sure na you're only saying kung hanggang saan ka sure. Pag nagbigay ka ng digits na lagpas sa ma-justify using your that can be justified, then it's already wrong. Ngayon, yung pag nag-check naman kami ng mga papers, usually ginagawa naman namin, as long as pwede kasing magbigay ka ng answer na, let's say yung final answer we know up to 4 digits na significant. Pwede kasing palya yung last digit. Pero kung malapit naman, sige, pagbigyan na. Kasi pwedeng round off error yun Pero kung talagang malayo, mali talaga.
Mali po talaga.
Okay. Ngayon, so for next meeting, ang gagawin natin ay pag-usapan natin yung 3B. I think yung mga advanced level din niya. Useful na mapag-usapan kasi ang dami niyang marami siyang ways, maraming lessons na lumalabas sa'yo pag ginagawa mo yung exercises So we'll talk about that next time. Yung 3.4, hopefully magawa rin natin kung hanggang saan sa Tuesday. Tapos yung estimation kasi, kaya pinili ko rin to kasi yung first chapter ng Resty, Halliday and Walker also does estimation, but it doesn't have enough examples. And kaya gusto ko na makita mo to within this context. Scientific notation, I have a subsection from book 2 of this series. So we'll talk about that as well. Yung math, ganito. This is for next week. Pinag-isipan ko pa, kung anong gagawin na sa math is something na, pinag-isipan ko pa Kasi, may sesend ako na document. Gusto ko na tingnan mo to. Yung document na to, yung DepEd na syllabus. So, ito yung supposedly dapat natututunan sa grades 1 to grade 10. So, Tapos ito, in-specify nila up to so how many meetings for this topic? So, tingnan mo lang yung grade 7 to grade 10. Tapos, i-mark off mo. Ano yung mga hindi mo na-encounter before? Tapos may mga I'm also going to send out some things to solve so it can help you diagnose what you know and what you don't know. Okay? So sa ngayon, naubos ng physics yung beginnings of physics. Although this is also part of math.
Opo.
Kasi tingin ko this is important enough na it's worth thinking over slowly. Para hindi mo na pag-isipan yan pagdating sa UP, yung mga tao, surprisingly, well, not really. Ang daming freshmen na hindi alam yung mga topics, yung mga bagay na to na kailangan mong usually yung mga ganito, may encounter mo yan sa labs. So, we have to take extra time just to teach this sa mga freshmen. Anyway, we'll stop here. I'll see you again on Thursday. Bye-bye.
Thank you, sir.
Thank you po.
Thank you po.
Bye-bye po.
Bye.